Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello friends, in this video we are going to study about resistance thermometers, also known as RTD. In this video we will study the principle of working, construction and applications of RTD. So let us start with our topic. Resistance thermometers, they are also known as resistance temperature detectors, or its short form is RTD. These resistance thermometers, they are the resistive transducers which measures the change in temperature by measuring the change in resistance. Okay, so they are basically used for the measurement of temperature changes. If we want to measure the temperature, we are having the thermometers for measuring the room temperature. For body temperature also we are having the thermometers there. So just like that, if we want to measure the temperature changes in the metals, what we do, it is very difficult to measure it directly, the variations in the temperature. So indirectly we are measuring the temperature changes by measuring the change in the resistance, because as the temperature changes, the resistance of the metals also changes. Okay. Now, how the resistance is changing with respect to temperature? We know that resistance is defined as the property of the material to oppose the flow of the current through it. Okay, so in a metal or in a conductor, if more amount of current is flowing through the conductor, it means that its resistance is very less. If less amount of current is flowing, it means that it is having a high value of resistance. Now this resistance, it not only depends upon the current, but it also depends upon the temperature. Now when this conductor, it is heated up, means that a thermal heat is provided to it, thermal expansion is given, then due to that thermal expansion, the electrons, because the current flow is all the flow of electrons, so the flow of electrons, it increases due to the thermal heat. So as the flow of electrons is increasing, the flow of current also increasing, and we can say that the resistance decreases. So we can say that there is a relationship between the temperature and the resistance also, that as we are increasing the temperature, the resistance of the material, it decreases, because when temperature increases, the flow of electrons increases, the flow of current increases, and the resistance decreases. So we are going to use here the relationship between the resistance and the temperature to measure the variations in the temperature. Okay, so that is the principle behind the working of the resistance thermometers or resistance temperature detectors. So the principle behind its working is that the resistance of a conductor changes when the temperature is changed. Now how the resistance varies with temperature, there is a relationship between it. There is an equation which defines this changes. So the variations in the resistance with the temperature, here temperature it is in the standard units, that is in kelvins, and it can be represented by this following relationship, which is R is equals to R naught 1 plus alpha 1 T plus alpha 2 T square plus till alpha n T n, and this continues in this way, means alpha 1 t plus alpha 2 t square plus alpha 3 t cube plus alpha 4 t raised to the power 4 plus alpha 5 t raised to the power 5. So in this way this equation continues. Now here this R is the resistance of the metal, and R naught it is the resistance at temperature T equals to 0 kelvins, and alpha 1, alpha 2, alpha 3 till alpha n, these are the constants. So the resistance thermometers, they uses this change in the resistance with the change in the temperature, because as the temperature is changing, resistance is also changing. So they are utilizing this principle that the change in resistance to determine the temperature changes or to measure the temperature variations. So that is the principle behind the working of the resistance thermometers, that the change in resistance is used to measure the temperature. Now comes the construction of the resistance thermometer. If we talk about its construction, then the resistance thermometers, they most probably they use the platinum as its constructing material. Okay, these RTDs, they are made up of platinum. Okay, now here we can use metals and semiconductors also. Metals, they are having the property that they have a positive temperature coefficient. Positive temperature coefficient means that their as the temperature increases, their resistance also increases, whereas in the semiconductors they are having the negative temperature coefficient. That means as the temperature increases, their resistance decreases. So for the construction of the RTDs, we are using the metals which are having the positive temperature coefficient, whose resistance increases with the increase in the temperature. Now for the construction of the RTDs, most probably the platinum is used. So platinum is used because it is having the advantages that it is having that platinum has the property that it can withstand high temperatures and maintain the excellent stability also, and also it is a noble metal, so it is very less susceptible to contamination. So due to these properties, platinum is used as the standard material for the construction of the RTDs. And also the metals can also be used because the metals, they have the property that they have their resistance will give a positive change with the changes in the temperature. Okay, so that is the main function of the RTD, that with the temperature changes the resistance also change, and they require a positive temperature coefficient. So most of the metals are having positive temperature coefficient, so they can be used for the construction of RTD. But mostly, and in most of the cases, platinum is used as the standard material for the construction of RTD. Now let us see some of the requirements which are expected from a conductor if it is used for the construction of RTD. Because here I have said that platinum is used, but also the conductors which are having positive temperature coefficient, they can also be used for the construction of RTD. So let us see the requirements of the material which can be used for the construction. So these are the requirements of the conductor material which is used in RTDs. First is that it should have a positive temperature coefficient. That is the first and the foremost requirement. Then the change in the resistance of the material per unit change in temperature, it should be as large as possible, so that if we are doing any minute changes in the temperature, the change in the resistance should be so large that it can be measured easily. So change in resistance per unit change in temperature should be as large as possible, so that it can be measured correctly and quickly by the RTDs. Then the material should have a high value of resistivity, so that minimum volume of material is used. We know that the resistance, it also depends upon the resistivity rho. Okay, so if the resistivity of the material is very high, then we have to use a very small amount of material for the construction of RTD. Okay, but if resistivity is very less, then a large volume or large mass of material has to be used. So it is expected that this material, it should have a high value of resistivity, so that only a small amount of material can be used for the construction. Third is that the resistance of the material, it should have a continuous and stable relationship with the temperature. Okay, the resistance should have a continuous linear relationship with the temperature. Then only we can measure the change in the resistance, and we can measure the temperature variations. Okay, so there should be a continuous and stable relationship with the temperature. So these are the requirements which are expected from the material which is used for the construction of RTD. Now let us see the basic diagram of an RTD, that what are the main parts of an RTD, how it is composed. So this is the basic construction of the RTD, how the platinum resistance here, the material which is used for the construction of RTD is the platinum. Okay, these are the connecting leads, these are the mounting leads, lead support sheath, and this is the element. So here the element is the platinum which is used for the RTD construction, and when the temperature variations, that when temperature is changed, the resistance of this element is going to change, and with the change in resistance we will be able to measure the changes in the temperature. Now, as I have said that mostly platinum is used for the construction of the RTD, but other than platinum, gold and silver, they are also rarely used for the construction of RTD on account of their low resistivities, because these gold and silver, they are having very low value of the resistivity, so they can also be used sometimes. Also tungsten can also be used, where tungsten has high resistivity, but it has the advantage it has very high resistivity, but it is reserved for the applications, for the high temperature applications. Because it is very brittle, okay, it can easily break and very difficult to work, but it has the advantage that it can work for the it can be used sometimes for the construction of RTD, of the RTD. Other than this, we are having copper. Copper is also used occasionally for the construction of RTD. Now, other than these gold, silver, tungsten, copper, mostly we use platinum, nickel, and their alloys. Okay, so sometimes gold, silver, tungsten, copper, they can be used depending upon the application for which RTD is used, but most of the time the platinum, nickel, and the alloys of nickel are used for the construction of RTD. Platinum being the best choice in that, because it is having a very single value for the resistance, that is 100 ohm at 0 degrees Celsius with a resistance temperature coefficient of 0.00385 per degree Celsius. So that is the resistance temperature coefficient. You can see that it is having a positive temperature coefficient. So that is why platinum is the standard and the best choice for the construction of RTD. Now if we see the characteristics, that how the temperature and the resistance are changing for these materials, if we see the graph for it, so these are the resistance and temperature characteristics of the materials nickel, copper, and platinum. You can see that for the platinum we are getting an almost linear relationship. For nickel it is something non-linear type, and for copper it is also linear, but after the temperature increases it becomes non-linear. Okay, so platinum is most probably used because it is having the linear relationship between the resistance and the temperature. Now if we see the characteristics for a small period of time, okay, like for small temperature range, if we see the changes in the resistance, we will see that we are having a linear relationship. So for these graphs, the characteristics graph, we are having two type of approximations. One is the linear approximation, which we will consider for a short range of temperature, and another is the quadratic approximation. Let's see that what will be the relationship between the resistance and temperature in these two types of approximations. In linear approximation, we will have r theta equals to okay, means linear approximation means that between the resistance and the temperature we are having a linear relationship. We are minimizing the curve, or we are considering the curve for a short range of temperature. So in that case, the equation which we have studied earlier, which is r equals to r theta 1 plus alpha 1 t plus alpha 2 t square, so that equation will be reduced. It will be only this will be left. Okay, now initially in that equation we were having r naught, which is the temperature at 0 degrees Celsius. Now here we are considering the material which is earlier at temperature theta 1, and after that the temperature has been changed and it is theta 2. Okay, so we want that when the temperature is changed, what will be the effect on the resistance. So here r theta is the approximate resistance at theta degrees Celsius. Then r theta naught, it is the resistance at theta naught degree Celsius, and del theta, it is the difference, that is the change in the resistance, that is theta minus theta naught. So temperature changes are from theta 1 to theta 2. We are changing the temperature from theta 1 to theta 2, but we are considering a temperature which is in between this range, okay, where we are getting a linear relationship between the resistance and the temperature. So that linear relationship is between here. First the temperature is theta naught and it is changed to theta. Okay, so this difference in the change or the change in temperature we will calculate by using this formula, by using this linear approximation. Now what about the quadratic approximation? Because here we are having linear relationship. In quadratic we will have quadratic relationship between the resistance and temperature. So in quadratic approximation, r theta so here you can see that we are having the linear part also and we are having the quadratic part also. So this is the linear fractional change in the temperature and this is the quadratic fractional change in the temperature, and all the other terms, they are the same. Okay, so in this way, when we want to consider the or we want to find out the changes in the temperature for a short range, we can use the linear approximation, and for a greater range we can use the quadratic approximation also. Okay, So in this video, we studied about the resistance thermometers, which are also known as the resistance temperature detectors or RTD. We studied that what is the principle of working of RTD. Then we see the construction, the platinum which is most probably used for it, its characteristics we have seen, and we have seen that how the linear and the quadratic approximations are done on the curve for the resistance and temperature characteristics. So in this so I hope that you have this topic will be clear to you now, and thank you.